Fire hydrants are used to transport water from a water supply system. In dangerous situations, they are used by firefighting services. In a water supply system, they can be used either as a vent or as a drain, if installed at its highest or lowest point respectively. We will learn about the facility manufacturing them and about relevant production methods during our visit to the Industrial Fittings Manufacturing Plant, AKWA, a company that was the first to launch into the Polish market a hydrant with water consumption monitoring. Let's go to Gniezno. Components of the water supply infrastructure are manufactured of cast iron, an alloy of iron and carbon and several other ingredients. They are melted together in cupola furnaces. Their shaft-like design, enabling feeding of the batch from the top, remains irreplaceable, even in the most modern foundries. In furnaces, the required temperature is achieved using coke, supported by highly oxygenated air pumped inside. A cupola furnace swallows 500 kilograms of batch material all at once. Liquid cast iron is supplied to all production lines using a turntable. Now we will see how cast iron is formed in a machine with a vertically divided mold. Up to 400 molds are prepared here every hour. They consist of molding plates, and the mass is injected between them under pressure. Cast iron is poured over the prepared packages. After cooling, cast components are transferred onto vibrating grills, on which the remains of the molding compound are shaken out of them. Then they are transported to a cooling tunnel. Now we can see how components of the water supply infrastructure are processed on a milling machine. Operations such as facing, drilling, or threading of openings are performed automatically, and the machine generates the required rotation itself. The employee only changes details on the table and verifies the quality of work. Lathes are used to process details of hydrants and gate valves. Every machine performs different multi-purpose operations. At these stations, we can see how stems are being processed. Finished details are transported to a powder coating station. Before they are coated with paint, they are placed in a sandblasting machine to remove all contaminations generated during the technological process. The cleaned component is fed into a computer-controlled gas furnace, where it is heated to 220 degrees Celsius and then transferred to a coating bin. Two coating methods are used: fluidizing by immersing, and electrostatic by applying powder with a special gun. And what about the color? Drilled parts and gate valves are painted blue, while components of the hydrant are painted red, in accordance with fire prevention requirements. When coating is completed, it is time for tests. First, the coat thickness is measured, and it has to amount to at least 250 micrometers. The measurements are performed with a digital measuring device. In the second test, the layer of paint is tested for its resilience to puncture, using 3,000-volt electric current. This is followed by impact test performed with a 0.5 kilogram weight. Now it is time to assemble everything together. We are in a hall where, under and overground fire hydrants and all associated fittings are being assembled together. Apart from assembling activities, here hydrants also undergo tests and labeling, and are prepared for transport. We are witnessing control tests performed for a gate valve. Under pressure of 18 bars in an open position, and 25 bars in a closed position. All products hold a hygiene certificate approving them for a contact with potable water. It's done! AKWA holds certificates for conformance with ISO 9001 and GSK, a certificate confirming the quality of coatings. All over Poland, products from the company ensure an efficient operation of water supply systems and water supply by hydrants. Because AKWA means water.